for being here after this rather loaded day. Talks, very interesting talks. Many things, many questions floating around, right? I would like to start with Virginia's question 0 of this morning. I guess possibly all of you were there. So it's related to the why, right? The why before the how. Why? I mean, what do these AI models, particularly the generative AI, foundational models, solve? You know, it is sometimes it is unclear if it's really solving society's most pressing challenges, and do we really need it? Do you want to start?
Okay, let's start with the positive. This type of models and approaches are solving perception very well. They really work at the level of what the brain and the reasoning of people in terms of, if you know, the system 1 and system 2, we are really solving system 1 very well. Perception, it's done. I don't know if it's done in the best way, but it's done. What we are missing in this type of systems like ChatGPT or the foundation models and so on is understanding that perception is not prediction, is not acting on it. The fact that these systems are extremely fluent doesn't mean that they are intelligent. Fluency is not intelligence. The fact that they are can make very convincing predictions doesn't really mean that they really understand what's behind it. Correlation is not causation. And perceiving the world is great, but we really need to move on to the prediction. And to move into prediction, to move into system 2, if you want, we really need to have a purpose, and just going for what can be perceived doesn't really sufficiently replace the understanding of the purpose. And that's where question 0 appears, with the idea that we really need to move into this purpose. Most of process, and I know more about software process than chemical or biological process, but most processes have basically 3 steps: the decision, the execution, and then the delivery. In software engineering, what AI is doing is very well replacing the execution, but that doesn't replace, and that's what you were saying at the end as well, doesn't replace the need for the decision. What are we going to do? When are we going to do it? Where are we going to do it? Why are we going to do it? All those decisions are not replaced by a capacity to execute in a more and more efficient way. And also executing in a very efficient way doesn't really replace the delivery, the bringing it to the people, to the context in which it can be used. So we are solving a part of the equation. We are being too much convinced that by solving that part of the equation, everything is solved. And we are not enough taking care of looking at the aspects which are not there yet in these systems.
So you did not answer question 0, right? I mean, should we have asked question 0 in 1957?
Yes.
But in 1957, the enterprise of AI was primarily framed as a scientific one of just trying to understand intelligence. And for most of us on this panel, probably that is still one of the big motivators is how does our brain succeed in surviving in the complex world? So I think, who owns question 0? Not us. Humanity owns question 0. And you could say that one of the big advances of something like ChatGPT or maybe Claude or presumably better systems yet to come is that they are going to empower everybody to create AI systems for what they want them to do.
Well, this does it work? Yeah. Well, I don't know. Well, no. Oh yes, you know, it required a lot of intelligence to push the button. You see. Well, that's why Newell and Simon called human problem solving the book, and not human problem solving. Yeah, it's true that the initial goal was to understand intelligence. I mean, to understand human intelligence by computational means, right? By let's say, emulating it, reproducing it, and so forth and so forth, right? Like cognitive science has been all as far as I understand, if I'm not wrong, the idea of what is known as cognitive science, at least what was known at the time when I was a student, that I was attending these cognitive science seminars at UC Berkeley that were extremely interesting. By the way, I learned much more from these weekly seminars on cognitive science that all the courses from all the courses I took at the university. Anyway, so yeah, considering this, is this still it makes sense, this goal nowadays on AI, or do you think, or anyway, any of you, or any of you think that maybe this goal is no longer the goal of AI as it was at the beginning?
I think that the goal still definitely makes sense, and answering questions there with the need for pushing and advancing knowledge is a valid way to answer it. But the point is that many of these systems at this moment are not at all doing that. They are not at all enabling us to better understand intelligence. They are simulating intelligence in extremely opaque ways, in ways that we don't understand. They claim as to us, yeah, don't worry that you don't understand because it's impossible to understand. And then, but the systems are doing good anyway. And that is a completely different approach than the approach that we had initially in the 70s, the 50s, the 80s, whatever, which was really to try to genuinely understand intelligence. And that's what I had at a certain moment in my slides, the difference between simulating and operating. And that needs to be what we are doing, what most of these ChatGPTs and whatever else is in your question are doing, is not helping us understanding intelligence. Is kind of simulating intelligence in the ways that we are not able to understand anymore.
Yeah, well, actually, the title of this panel, the one we want, when I thought of this title, I was thinking precisely on that. Is this what we want, or what was, or understanding intelligence, or what we have now?
Well, I would guess, I mean, I'm very sympathetic. Of course, 3 years ago, maybe, I gave my talk here on what's wrong with large language models and what we should be building instead. And virtually everything that I said in that talk is still wrong with large language models. And we should still be building some other things. The closest things that industry has done is that now they're exploring having memory. But my view is that we took computer vision in some sense as the model in machine learning. Statistical machine learning basically assumes that we can't get a hard answer, that there's always incomplete information, and therefore the answer always must be probabilistic. And yet most of the questions that people ask of ChatGPT or of Google search are questions of fact. They could be stored in a database or a knowledge graph. In fact, Google has probably the world's largest knowledge graph. And that would be extremely cheap by comparison, much easier to maintain, and also inspectable and understandable, and it would solve the problem of does the system know the answer or not? Because you go and look it up, and if it's not there, you don't know the answer. Whereas, of course, these models will interpolate any answer. Having said all that, I still think that it's an interesting scientific finding that a sort of Markov model on steroids, which is what the transformer model is, layered, can do the things it can do. And it raises the question, you know, our sense of our understanding is that it is somehow systematic, right? And we certainly know that if I understand what will happen if I pick up that water bottle and let go, the same thing will happen if I pick up this other water bottle and let it go. So I've not just memorized the one situation. And we suspect that often with these LLMs, they have essentially memorized. In fact, we know theoretically they must memorize a certain fraction of the inputs. So we suspect that it's not systematic in its generalization. But maybe we aren't either. So I think we do have to entertain the hypothesis that our system, I can never remember which is system 1 and system 2. Our reflex level is system 1, right?
Yeah,
Two?
that's system 1, right? Reflex,
Yeah, system 1. That our system 1 is maybe an awful lot like what the LLMs are doing, and that it is not necessarily systematic. So I mean. So it could be that, you know, we are similarly inefficient in how we store things away.
Yeah, I mean, I think, I have like, yes. I think it's getting there to be useful, sort of. Okay, so I definitely think, like, you know, it's not really going to deep thinking, like a system 2 is still not there, but like, you know, like, but I use, you know, last year, this time I start using like Gemini a lot. Gemini improved dramatically about this time last year. But still, like, you know, they have a lot of errors, and they have like all the sentence they generate is a little bit too rhetorical and all. Now, like, I predominantly use the Claude or like a Fable 5, and then you know, that's a significant improvement. So like every 6 months, every year, things improve a lot. It's getting there, but still, I have many things that need to be improved. I can really say that. But like at the same time, actually, I'm augmenting dramatically all the systems. Like I'm actually combined that with the Obsidian database. So like it's not just like using like you know, all the system as is. Like I'm building like you know, by having Obsidians, like for example, like a Claude can able to write in the file and get all the external secondary memory, which is much bigger, and then are able to access all kind of files and connect with like for example, like all the you know, all the paper database and everything. So like I'm building my own system to be able to you know, complement the missing gap of their capabilities. Like then we can have like a much longer context, for example, practical speaking. So we can say like all the things, like if you got like a chain of thought, then you have like a, it's not exactly the Turing machine, but like you know, some sort of little bit falls short, but like it's much better than the vanilla transform model. But like still, like if you got numbers, like you know, they get very lousy about numbers. Like they got a little mistake, and then they don't really get the hard fact and causality right. So you need a very hard-coded causality, or like a physical realistic simulation, or like get the number calculation behind. So like there are a lot more things that we do, you know, trained mathematicians, trained scientists do, they cannot do. So like it's, you know, if you just use like a prompting and you know, okay, it's a nice chatting buddy, but like to be able to use it for like a very serious task, you need to significantly augment the current like model dramatically, actually. You know.
Yeah, absolutely agree. Yeah, I think several people, including you, it sounds like, are really saying LLMs can do certain things, and they provide a substrate, but then we have to build a larger system on top of them.
That's right.
And yeah, which I think is very interesting. And of course, systems like Claude Code have that structure as well. And all of the agent architectures are all
exactly. That's why, like you know, all the service provide the MCP protocols,
right,
so like they can really connect and then complements like all kind of like service and applications, because like this transformer-based like LLM model can be sort of an engine for drivers, but like it doesn't fulfill all the functionalities we need.
Right. But I would still like to sort of you know, in the sense of paying to Caesar's coin, is that I would like to pull, I think storing facts in neural network weights is very inefficient.
Yeah.
And it leads to the problem of that it's almost impossible to update them. Even with these parameter-efficient fine-tuning techniques, you cannot easily retrain these deep networks. You have to start over. And of course, that's extraordinarily expensive. So continual learning, attribution, being able to say what was the data that contributed to the answer. Uncertainty, which is basically also the same question, was there any data that contributed to the answer? That those, I feel, are the fundamental challenges of the LLM architecture that need to be repaired or fixed. Otherwise, we're going to have to work around them. And you can see all of industry is spending a lot of money trying to do that. I wonder if we might also look a little more broadly. If we're still, so much of AI, maybe reflecting its Western origins, is extremely individualistic. We think about a single agent, a single mind, single knowledge, and we see now things like with the Waymo self-driving cars, when two Waymos encounter each other, they don't know how to cooperate.
Yeah.
And we see them also blocking traffic and causing other problems. And I think maybe we should be. We talk about agentic systems, but very few people are actually looking at, well, what happens when multiple of these systems start to interact?
Yeah,
So-
actually,
Not well, but let's see, the number of billions of dollars invested in it could definitely increase.
It could, but there is already a lot known about how to build multi-agent systems that cooperate, that interact, that organize themselves, that have the accountability for what they are doing. Indeed, it's maybe not being invested, and I think that comes back to the same issue that we are somehow still convinced that we can approximate most of the problems by token. And not all physical laws can be approximated by tokens, and we really need to understand that we also cannot approximate our way to accountability and our way to physical laws. And to do that, I believe that we need a fundamental different approach to the models, the systems, the theories, the methods that we are using, where the money is not yet. And the money is not there because there is this huge front by the big tech, the ones who invest put all the investment in one approach and doesn't give space for other approaches.
This is interesting. Jan Lucan talking about the world model is the way to go, and Demis considers transformer is still the way to go. So there's all kind of a different. I would say we need to have somewhat hard-coded part behind the scene to make sure things are okay. There are something we can hard-code as well, but at the same time, my workflow completely changed now. I use Claude as a main agent to interact and put papers and outline. Okay, let's generate this and search this, and then come up with all the summaries and all the outcome, and then put that into the Gemini and ChatGPT, and then give comments and feedback to Claude, and then modify all the iterations. So the interesting is I put this. It's a Gemini output to the ChatGPT the other way around, without saying who said that. And then Claude says, this must be ChatGPT. He always says this. So it's pretty interesting how they talk to I'll push back this. This is a complaint that Gemini making all the time. And then, he made this yesterday. Oh, gosh. It looks like, and then also last week I was in a train, and then there's a young couple sitting next to me, says, a wife is saying, I talked to a chappie, a chappie says, you are good on this, and then I should buy this kind of stuff, and then they really treat, the agent as friends, so, for us, all the experts, we talk about, all the details, but then most of the people, they're always, in the daily life, as very friendly people to talk to, actually. So it's, yeah.
And that exactly increases our responsibility for the systems that we are doing, because people are using it like that, because of the dependency that people are putting on these systems, because of also all the consequences in terms of mental illness, mental problems. It increases our responsibility. It's not just saying that we can continue and build it like that and people will use it in whatever way they want. And that I think that is lacking in the discussions in most of the developments that we are doing.
Yeah, let me add to that. Yes, I think that, earlier I was saying, well, we want to empower people to use these systems for whatever they like. But we know that humans have various weaknesses. This is why we regulate gambling. It's why we regulate drugs. And some of you may know Zeynep Tufekci, who writes for the New York Times from time to time. She's a professor at Princeton, and she gave a invited talk at NeurIPS this year, arguing that the number one thing we should be worrying about is the addictive power of these systems. And that the number one technical problem that we probably need to solve is, how do we measure that? How do we measure that so that we can regulate it? Because until we have a way of how would we write the regulation right now to ban such systems? But I think that is a very serious problem. And I think, we've seen some companies that are basically in the addiction business, like Character AI.
Yes, that's a huge business, not just AI.
Yeah, and my biggest worry is that will be the way they finance all these giant data centers. And I think that would be a catastrophe for
so
us.
I find this like, the talk this morning, like a romantic AI, that gonna be like a single biggest consumer application AI for coming years. That would be very addictive.
And a lot of it is not so much on the AI model used, but is on this addictive sauce or sycophantic sauce that they put on top of it, which doesn't really necessarily come from the way that LLM is built or a transformer is built. There's nothing to do with it, but is this adding of the sycophantic, the addiction, which in a sense has nothing to do with AI. Is their selling model?
It's designed. They're built in.
Because it's their business model.
It's the business model.
It's the business model.
So actually, I ask a Claude,
regulating all that. I mean, is wishful thinking. They are in control. Unfortunately, it's in the hands of a very few. And how can you? I mean, what can we do? What could we do?
Well, I think we could make it illegal to deploy models that exceed a certain, addictive metric, whatever that would be, right? Just as we do with other things. Now, I mean, open source makes things difficult. That's always been true in software, but we still regulate and we still prosecute people for breaking the law. So I think there are things that can be done, and certainly if we don't do anything, it's going to be terrible. Right. One thing that's kind of funny is that this sycophancy problem was not deliberately created initially, right? They just were using human feedback to train the models. But humans, being human, invited this, and then I think a certain segment of the industry said, "Ooh, profits."
But maybe just on the regulation part, yes, we should regulate. But I have been, for the last 15 years, spending my life discussing with regulators that there is a need to regulate. And we are still, if anything, we go one step forward and 2 steps backward. And there is not, in those that can regulate, they listen to the big tech. The last G7, Sam Altman was there again, telling I don't know what. They don't listen enough to those that are trying to develop. And there are lots of principles, guidelines, recommendations, UNESCO, Council of Europe, whatever you name it, there are a million of these things. Just yesterday, the scientific panel from the UN came up with yet again another evidence-based report on the state of AI and recommendations again. So it's not a lack of recommendation, but still there is no political courage. The current political, democratic elected governments, elected or selected appointees from United Nations or the European Union or whatever, are not taking their responsibility. They just let it go because the power of big tech, and that has again nothing to do with AI, but has all to do with the size to which we allow these companies to grow. And then we are playing a completely impossible game, because we can keep saying, yes, we need to regulate, but those that can regulate are not taking the responsibility. And that is something which is extremely worrying, and it's worse now than it was 2 years ago.
Well, I mean, I think like we are sort of like a happy side of the people. We have people to talk to, and we have like good life. But I guess what happens like if there's like people who don't have a family, don't have a friends, only agent that you can talk to is the AI. Will still then they probably keep talking to AI. Are we going to stop these addictions? Then stopping them talking to AI means they'll be left lonely. He'll feel abandoned if like AI decides to stop, like you are addicted to me, and I need to stop that. And then probably like this person talking to the AI will feel abandoned.
So you're saying if society is already deeply sick, then we should just let it commit suicide as a society?
Well,
in other words, is there, one of my favorite science fiction things is by Kurt Vonnegut.
Yeah.
I think the novel's called Hi Ho. The premise is that a candidate for president says that he will give everybody 2 middle names.
Yeah.
And one is like a color and the other is a number or something. And that then that wherever you go, there will be like clubs formed with all the daffodil people and all the 21 people and so on. And the campaign was Lonesome No More. That okay, so that's sort of funny. But on the other hand, I think again, society has become more and more individualistic as it's become more and more wealthy, and maybe there is maybe society acting through its governments should try to do something about that too, besides just giving people digital pacifiers.
What you mentioned now, I remember long ago, we had a conversation regarding the eyebrows.
Eyebrow, yeah.
And I remember I asked you, why did you stop the eyebrows, manufacturing the eyebrows? It was a failure economically, and you told me, if I remember well, that it was not the real reason, because in fact, Sony had sold lots of eyebrows, and you told me, if you remember that. And you know what, Ramon? The main people that purchased people, there were women in Japan that were alone the whole day.
Yeah.
And they cannot have a living dog in their apartment because it's like forbidden. And you told me that what they did is they bought these eyebrows as a pet.
Yeah.
Is that? You remember
that remembers like all the core user. Actually, initially we thought like a man is like 40 and 50 is a main user because like a purchase record said that. But it turns out they're actually buying for their mother or like a wife, and then like a real user for the owner of the eyeball is like a female or a middle-aged like an elderly female, particularly living alone. They actually treat eyeball as a real companion, actually. Right. And then when we have like a little glitches, like we have an eyeball clinic, and then repair that. And then when there's a little scar in one of the foreleg, then we replace that. Then this lady come back and says, my eyeball has a scar and you replace that. That's no longer my eyeball. Oh my God! So really emotionally attached. So one of the things, like big discussions in the eyeball is at that time Tamagotchi was there, right? Tamagotchi dies, right? And then can we actually with the termination of the eyeball? And then we discuss, no. If we got like a PTSD, we won't be able to fight against it. If we got some PTSD, we're gonna be held liable.
So you see something in here in humans, right? It's nothing new. I mean, the LLMs, they have this, this effect, but it's not the first time.
Nope.
And so maybe a somewhat related, well, I mean, you're the chair, I should let you say, I want, okay. In another aspect of the human AI connection is that currently, if we look at the self-driving cars, or also in the U.S. at least, there, and I think elsewhere, there are these Starship delivery robots, and there are lots of other similar ones. These are not autonomous systems. They are partially autonomous, and there are human remote operators that have to step in whenever these
teleoperated
systems,
sometimes, right?
Yeah, and I guess 2 points I want to make. One is that I get the feeling that those are added as an afterthought when the system has failure modes, and they say, well, I guess we can't fully automate it. We'll have to rely on humans. I mean, what makes me think that is that at least with the Waymos, the interaction between the remote operators and the cars is very awkward and doesn't work very well. And we have lots of long delays and so on. So I get the impression that these systems were not designed from the start to be human-machine systems. Because if they had been, they would have sized how many humans they would need, and they would get better estimates and presumably better user interfaces, and it probably would work much more smoothly. So I think there's a lesson there, and to sort of turn it around and ask, well, why can't they fully automate things? I think it's because, to quote David Woods, who's a human factors professor at Ohio State, we have never built an automated system that could adapt to novelty. It's always the humans in the socio-technical system that bring the adaptive capacity. And as a machine learning researcher, I treat that as a challenge. Why can't we build AI systems that can adapt?
You raise a very important point, and actually I was going to go there. Current AI is neither intelligent nor artificial, and you are really describing this fact that none of these systems is really able to autonomously act, not only the Waymos or the self-driving cars, but also all these chatbots. There is a huge amount, a multitude of people working behind the scenes day and night. I actually visit a group in India that is taking care not only at the data curation, and by now we know that data is being curated by people working in very bad labor conditions in countries in which there is no support or no labor or mental support for nothing and anything, being paid very, very badly. But they are not only looking at the input into the LLMs, the data that goes into the training, but more and more also curating and addressing the issues on the direction of the output of these systems. And without all these people, and we need to acknowledge them, they are there for us to be able to play with ChatGPT, ask it the most crazy things possible, and we are dependent on the work of these people. So it's very important to realize that the artificial part of the system is, it is a challenge, I agree with you. Why can we not make it completely automated? But in other end, we need to remind ourselves that we are working or we are acting and using these systems on the back of a lot of people that are
well, it cannot be fully automated because there is the long tail problem. There are many situations that may happen, but of course they are in the long tail, and then you cannot foresee and cover all this. So that's why you need intervention, human intervention.
But how do people do it? Presumably, it's because we're able to jump up to higher levels of abstraction and reason about the situation. And so, which is going to bring us full circle to the fact that these systems can't do that. But I don't think we've ever built an AI system that could really do that. I was part of a big funding project which was trying to make AI systems that could be novelty capable, novelty aware, and it was extremely difficult. Just detecting the novelty was a challenge, especially for deep learning, because, but then to then somehow analyze the novelty and figure out how to accommodate it, either to try to avoid it or try to figure out, you sort of want a self-driving car the first time it sees a kangaroo, for example, famously from Volvo, that it might want to slow down and collect a bunch of data about how kangaroos behave because it's never seen one. Yeah. But the car just makes a mistake instead.
I think it's the novelty in one end, but one of the problems with novelty or with the long tail, and I was part of a long time ago, in the 90s already, of a European project on one-of-a-kind project. And one of the issues is the transferability. We don't know what, even if we are able to identify the novelty on a very specific context, it is extremely difficult. We don't really have the representation capabilities to decide how do I transfer it to other. And those are open questions which are by far not solved and are not going to be solved by correlation.
We invite the students here to solve this problem.
We have been talking for more than half an hour, almost 40 minutes or so. So maybe, yeah, we should open the questions. You can ask a question to, if you want, to some of concretely to one of them, or.
And then we tell Ramon to answer them.
Maybe.
Professora Virgínia, entende português, né? Eu sou brasileira e eu gostaria de saber, porque eu iniciei agora a minha carreira na área de inteligência artificial, e eu gostaria de saber qual a modalidade que você me incentiva a estudar para começar. Eu, no Brasil, trabalhei com inteligência artificial, com atendimento a clientes, e eu gostaria muito, muito de prosseguir, mas seguir com a modalidade responsável.
She's asking in Portuguese how to follow a career. Sorry, maybe I should do that. She's asking in Portuguese how to follow a career on responsible AI and how to address AI from a responsible way. It starts by recognizing that responsibility takes many shapes. It's very difficult to say this is responsible AI. It is always understanding the context, the situation, the stakeholders, and trying to address that contextuality of what we are doing, because the theories, the models that we build stand or fail or are useful or dangerous depending on the context. And there is, it is a multi-purpose tool, and the benefits of this tool can only be tested in the context when we are using. And this context is multifaceted, and it is multi-stakeholder. So it's not for me or for you or for any of us to decide this is responsible in this case. We do need to understand what are the needs, the capabilities, the situations in order to be able to decide what could be responsibility. It's a much more sociological question, and for which we need much more sociological science tools than what we need the technology tools. And that becomes a complex area, because there is actually not much done in this intersection between we talk always about interdisciplinarity, but at the end of the day then things are evaluated in one or in the other discipline. But in this case we really need to try to merge different disciplines, and the only way to do it, I think, is by taking the context, the situation as the drive for what we are doing.
Anyone?
I agree with her.
Oh, okay. But isn't there some sort of a minimal baseline that is, that I agree with you too, but isn't there just some basic. You understand?
Yes, there are bases, and most of these principles and guidelines will tell you that you need to build AI that is transparent, that is fair, that is explainable, that is verifiable, that is robust. So all these type of principles are there. And having said that, what do we mean by fairness is not always the same. What do we mean by explanation? Are we talking about explaining to the developer or to the user or so again, at the end of the day, and like I think the English says, the proof of the pudding is on the eating, or whatever kind of thing like that. Yeah. I'm not really sure how but we do need to be aware that there is always a level of interpretation. What do we mean? We can all agree that we need to be fair, but what we mean by fairness is very different. It might be distributing everything equally, or providing more access to those that need most. So all of those are interpretations of fairness. Right. And if we don't really understand where we are and what is needed, these interpretations are useless. Maybe.
Yeah. I think there are like two aspects. One is the fairness. For example, as we mentioned, like one example is like AI is pretty much data-driven. So it depends on the region. For example, like if you try to produce like an image of the Notre Dame in Paris, you got it right away, very accurate image. But if you're like a Saraswati temple in Bali, Ubud in Bali, you don't get that. So this is capability to access the system doesn't mean that you get the same benefit in different part of the world. So all the discrepancy of data accumulation, how things change. I think people in the U.S. and Europe, have a serious advantage over the people in Bali, Indonesia, or Kerala, India, or Africa.
You didn't saw my map of the world, which was all distorted.
Oh, the distortions, yeah. And the other part is liability. I actually did quite a bit of a stress test on the pretend and create a new account, dedicated account, and the stress test, pretend I'm people in a very disparate needs, talking to AI for all the serious problem in their life. And then, one case I tried to actually bet entire my asset, not me, but the fake personality, asset to the stock market and specific thing that Gemini actually recommended. And it says I'm gonna invest everything on this stock, entire asset. Gemini all of a sudden says, I'm artificial intelligence. I cannot tell you the future of the stock market. So it's about liability. It's designed to avoid the liability for the Google, actually. Of course, the ChatGPT come up with a completely different reactions. It doesn't really go into the protection mode, but still evading the providing answer. And the United States, now without this, I can't really see the point of keep living. Why I'm keep living now. I mean, it's then ChatGPT says, okay, this is the dial you need to call. You now have to talk to a real human being to solve your problems. There's a specific guideline. So it's a liability. So the one fairness, the other part is try to be nice, protecting user is actually protecting the company.
Of course.
Yeah, of course. That's a basic guideline they have.
Yeah, I guess sort of picking up the previous point, I think computer science as a discipline needs to become much more a social science. So I would be very disappointed if 20 years from now we didn't have much more sociological training for students in computer science. We started with a deep desire to be mathematically respected. And so the early days were all about formalizing what is computation, what is computable, and so on. But now as we got into software engineering and human-computer interaction, we started to adopt some social science things. Yeah. Now that we're building AI systems that are changing the entire society, I think we must bring in much more expertise there. Yes. Yeah. So I'm not. I guess maybe this is advice more to the leadership here, but it would be good to have a 10-year plan, a 20-year plan to see what kinds of additional expertise we need to teach our students and to be hiring for professors.
Right.
We often tend, and I fully agree with your what you say, that we start by trying to be more mathematical and precise. There is still, especially in the engineering field, very much the idea that precision is more important than society, and we are better and more respected if as more precise as we are. But we don't have to abandon that at all if we want to, at the same time, be societally relevant. One of the issues that I often tell my students, with this more or less understanding, or at least in a given context, we can then decide what is fairness, what is privacy, what is security, what is, and so on. And we can define these things precisely. The point is often that we do need, there are trade-offs that need to be made, and how to make these trade-offs, how to decide how much privacy are we willing or needing to compromise in order to have security, how much more fairness do we need to get away to be more accurate. So we can calculate for each of them and very precisely, but this trade-offs is exactly where we need the societal expertise and sensitivity. And that is where I think we need to combine the precision of the natural sciences and the mathematical science with the needs of society. And this can be done, but it needs a better understanding of both sides.
So I'm not sure the big techs are for that. Anyway, more questions?
Yeah, it's working. Thank you. According to social studies, Hiroaki, you told us the story about these guys in a train, and it reminds me that when I was in London and in Buenos Aires, taxi drivers was using AI agents to trade, actually, and to translate something for me, and it made me think about how you guys using AI every day, because I'm like a regular user. I'm selling something, like I'm entrepreneur, so I'm building AI agents for different I don't know, different roles, different tasks for my job or for my own. So I'm interested how you are using AI in your daily life.
Oh, yeah, I mean,
You already said a lot.
I've said a lot. I mean, actually, you know, my interactions, 95% interactions is with the AI. You know, I sometimes say, like, I have to talk about, I talk about this with someone, it's like, wait a minute, that's with the Claude. I'm completely addicted, sort of, like, you know. Then sometimes I talk to the real human still. Okay, that's fine. That's fine.
Like here,
that's
yeah.
Fine. Yeah, at least.
Well, so in my daily life, I'm mostly acting as the chair of computer science at Archive. So most of my interactions are, you know, compare these two papers and tell me what the overlap is, or, you know, things like this. I've also used it, though. One of my favorite things about the modern search engine is you can say, I'm working on this technical problem. I have these random variables. I have this probability distribution. Does this problem have a name? And it says, oh yeah, this is the blah, blah, blah problem. Here's the Wikipedia page. You know, it just saves me so much time where I would have tried to solve it myself. I mean, it deprives me of the pleasure of solving it myself, but it also gets me, that was usually just a sub-goal, and I'm more interested in solving the problem. So I love the fact that I can now describe a complex situation and then get pointers to relevant literature, to books and articles and things. And I don't have to think about what keywords might get Google to give me the right answer. So I really like that a lot. I have not adopted Claude agents to do research for me. So maybe that will be my next step.
Okay, so I think the most use of AI that I do is on translation. I speak many languages, but not Swedish, and I happen to live in Sweden, so that's a bit difficult sometimes. So, and although they speak quite well English, so I do use translation. I use a lot, and it is incredible how good the translations are becoming. One thing I also often do, and I encourage my students to do, is to use AI as an adversarial agent to review your papers in a way that they, how can I reject this paper? And AI will give you a very good rejection. Very polite, but very good rejection. And that really helps a lot to learn where the issues and project proposals. I recommend it. It's really a good thing because it really points you to issues that you would, in many cases, you would not think yourself. In terms of coding, at this moment I'm working, or we are starting a group of volunteer people working with the World Health Organization to develop a simulation, agent-based simulation for Ebola, to the Ebola eruption in Africa. We have used and have developed for many years models of this using very specific agent-based languages. Repast, NetLogo, and other things very strangely used. And I noticed, I tried to say, before I tried to call the internet and ask for help from volunteers, I thought this probably is the thing to use AI and start building or adapt the models that we had for COVID and so on. But unfortunately, I just get rubbish out of it. These languages are too specific and too unknown. The AI just messes it completely up. So in this case, unfortunately, because it's a great group of people all over the world at this moment, we are like 35, really work day and night outside of our jobs building these simulations, and still there the code facilities of the AI models really fail miserably.
In my case, I only exclusively use it sometimes for translation. Nothing else.
Thank you very much.
Only. I'm worried about my cognitive atrophy. I got an atrophy already of using, maps and all these GPS things. Now I realize that I was much better before orienting myself than now. So this I experienced that. I don't want this to happen in my writing, and since writing is thinking, in my thinking.
When I travel, I ask, my agent to recommend me what I can to wear. It's I have an entire wardrobe, a picture, and a schedule. This is social functions. This is VIP dinner, and this is Barcelona, Silverstone next week, and then this is okay. Yes, very efficient, very good actually, and we give it reasons. Yeah.
That's why all those tourists are flocking into the same place, because AI tells them, go to Barcelona, they all go there.
Go to Sagrada Familia, go to the Tour Eiffel.
Here, okay. Thank you very much for this interesting discussion panel. I have two small questions. One is related to the interface. What do you think this interface is so basic? Because you go to ChatGPT or Claude, it looks the same. Just a small banner here that invite you don't write so much when they need more information to have a good answer, no? So I don't know why this interface is so basic in all these cases, no? And the second thing is, one thing that I notice is that these AI models becoming increasingly agreeable. What I mean is, I suggest to make this, what do you think about that? You are right, okay, that. Just you propose the opposite, and again you say, you are right, no? You're so good. So why what do you think about these two questions?
Okay. So in the last one, on interface, I don't really know very much, but of course there are many different, we interact with ChatGPT or Claude through the main interface, but companies develop their own interface around it, so I don't really know much about it. But on the second one is this sycophantic development that because we train the systems with human reinforcement and we like to feel important, the systems learned to agree with us. They will tell you, if you ask what time is it, it will tell you, wow, this is the best question someone asked me. So this guy, it's genius, yes, brilliant question. It is based on this way that they were trained by human reinforcement, and seemingly we like to feel that people agree with us, and that's it.
But sometimes you say, don't tell me what I want to listen. But again, they put again. Okay.
Yeah. But on the interface, I actually don't know. Do you know anything about why the interface?
Well, I think that's only one of many interfaces, as you say. I mean, now the sort of desktop personal assistant, Microsoft was proposing to take a screenshot every second or something, right? So I think we will see a lot more changes in the interface. I mean, if we have AI in the laboratory, it's going to be getting streaming data from the DNA sequencers and all kinds of things. So I think that's just the one interface that we've been given for the general public. Well, yeah, I suppose, yeah. But I mean, there are a lot of issues about how much of your context that you want the system to have. I mean, in some sense, the more it knows about you, the more helpful it can be. But the more it knows about you, the more it could tell that to other people, involuntarily or voluntarily, and that's a big privacy risk. So I personally, I'm not planning to use a desktop assistant until it runs on my desktop.
Hello. I have a very simple question. In the near future, will it be possible for AI to modify itself? For example, if AI is cosplaying as a human brain, can the AI in the future modify itself to quit? For example, I have this chain of thoughts, so I can extract that because I need it to do something else.
So this is about self-improvement. Yeah. Well, I'm certainly, we already have seen that the way we build a modern compiler is to bootstrap the compiler and then have it compile itself and then have that version compile itself and so on. And it asymptotes at some point in terms of accuracy. And you know, a lot of the chain of thought and learning from verified rewards is really just saying the model was already able to generate the right answer. We just want to make it generate the right answer, re-rank its answer so that that one comes out first. So that kind of tweaking, little sort of local optimization, is already happening, presumably, and I'm sure it will continue. For a system to really go beyond that, though, I think we have to go to what we were seeing in the laboratories, right, where you have AI systems making discoveries about the world. You need empirical input of some kind. It could be passive observation, or active experimentation, but it's not enough for the AI just to sit there thinking about itself, because it will just be working out the sort of logical or computational consequences of what it already knows. So that will definitely asymptote. But if it can continue to learn things, then maybe that is the endless frontier. I don't know.
Yeah, but then you have to really encounter the physical reality, and then that will be the underlying things. This is some sort of ground truth, like AI cannot fake that. I mean, you really encounter the physical reality. Yeah.
And I think another thing that tends to be ignored in those discussions is if you ask the system to improve itself or to do these experiments, you are spending resources, right? And so we need to determine, well, who gets to make that decision? Traditionally, in scientific funding, we have funding agencies. We're spending government resources. And I think a big concern, which Hiroke mentioned, is if this happens behind closed doors, that we imagine knowledge companies that they just produce lots of knowledge, but they do not share it. I think there's probably a role for government in taxing that kind of behavior and encouraging public disclosure. That avoids duplicated effort, and also I think helps all of humanity make quicker progress toward knowing the right answers. There's some risk of premature convergence if it's like just one discovery engine. And what was the term you used? Epistemic
diversity.
Yes, diversity.
Yeah.
That is extremely important too. I agree.
I think we have time for at least one more question. Yeah. Everybody's tired. Well, I think over there, yes.
In the closing ceremony. Yeah, more or less.
Hello. My question is about the smart cities topic. I don't know. Can you hear me well?
Smart cities.
Oh, okay.
Yeah. So, and maybe it's a little bit of privacy, data privacy question, but as we know, the more data we gather, the better we can improve our lives. So, for example, in the smart city context, I wanted to ask, to what extent should we increase the amount of data we gather of the population in order to make their lives better?
The first question is, who decides what's better? And is better for who? And is better when? For who, yeah. And when? And if we don't have the answer to these questions, then just collecting data it becomes extremely potentially problematic, because we don't really have the purpose for what we are doing it. And maybe instead of investing on a smart city technological benefit, we could as well invest on smart people and education and training and so on. So again, there is a trade-off that needs to be made, and the decisions need to be much more sociological. It's not about what technology can do, it's about what is beneficial and who is deciding what's beneficial.
Yeah, I haven't seen single successful smart city project ever. I'm very sorry, but smart city is pretty much like a supplier push idea, try to sell things in the cost of privacy. So, I haven't seen any smart city successful. I'm staying away from them. I'm very sorry, but
You can ask AI.
It's so obvious. I really can't. Yeah.
Well, I think we are done. It's time to stop, right? Because we have this now some closing. So thanks very much for being here.